My name is Jamie Riedessel. I'm a staff engineer and DevOps at HelloSign, which is a Dropbox company. Both of the author of software telemetry you see in the lower hand corner there. And it includes handling of a particular topic that doesn't get as much attention from people as they should. A lot of people pay attention to how they're handling data in their production systems, but these telemetry systems, these logs, traces, and metrics don't always get as much scrutiny in terms of privacy information and other stuff that they might. And structured logging is one of the better methods to try to help defend against leaks. So what we were learning about today is toxic data and what that is, the top sources of toxic data leaks going into your telemetry streams, the architecture of structured loggers, as well as how structured loggers can help prevent leaks. The three main types of toxic data are privacy information, financial, and health. Privacy information, or PII, the European GDPR sent a shockwave throughout the entire tech industry when it came out. It enforced in May of 2018, so it's been a bit over 3 years since this came out. And if you're in the industry at the time, you saw a huge number of email updates coming to your email saying we've updated our terms of service, and GDPR did that because what GDPR did is that it created a very sticky form of privacy regulation, made certain types of information private that weren't consistently considered private before, and it just made for a lot of work just because it applied to all EU citizens, even if you didn't do business in the EU. So a lot of platforms had to make choices about how they want to handle this. In the wake of that, the California Consumer Privacy Act came out, I think about a year or 2 years after that enshrined a lot of the same protections for California citizens. And since California is kind of a big part of our country, a lot of places that pulled out of the EU rather than deal with GDPR had to deal with the California Rights Act. And one little understood one is the Family Educational Rights and Privacy Act, also known as FERPA. I spent 7 years working in higher education, and this is a privacy regulation aimed at the educational market. Way back in the olden days, when you looking for test results, often you'd come outside the professor's office and you'd see printouts of names and grades, and you could just see what's going on. That sort of practice was banned by FERPA, and that's why these days you might see student ID and grade, or if nothing at all in some cases. And FERPA allows you as a student to go to, say, like the registrar's office and say, yeah, I would like to not be included in any student directories, because FERPA was also aimed at trying to reduce incidents of stalking. So that was a clear privacy directive that applies to a sector-specific privacy regulation. Health information, well, the famous HIPAA, the Electronic Private Health Information, came out in the 90s as more and more health records computerized, and the politicians caught up with the reality of how easy that stuff is to copy. Now, financial regulation has been considered toxic for a long time, but the most famous of that is the payment card industry standard, PCI DSS. But it actually started a long while ago. In 1970, the Fair Credit Reporting Act applied a lot of regulation to what was previously an unregulated market. And all it says in 1970s, this was actually a major civil rights regulation just because it, among other things, banned the practice of real estate redlining that caused such terrible segregation in our cities. Moving past that, the Right to Financial Privacy Act in 1978 also provided a lot more liberalization and allowed spouses to be financially private from each other, which is useful for women trying to get away from husbands and trying to establish financial independence. Because in 1978, often applying for a credit card required your husband's signature on it. The Gramm-Leach-Blaley Act in 1999 extended a few more. That was as kind of at the peak of the dot-com boom, so we saw some interesting things happen there. But there's another type of regulation that I do consider toxic, and that is security information. Passwords, logins, hashes, security questions, API keys, anything that would allow you to impersonate another user. And if this shows up in your telemetry streams, that can be a hassle. Now, unless you're working directly with government data, you're probably not dealing with any externally imposed regulation about this sort of data. But getting this wrong will get you on haveibeenpwned.com and the reputational hit that comes with. So yeah, it's major stuff. But this also represents an evolution. Privacy regulations have evolved over time. Email addresses are now private. GDPR did that. And that's a bit of a problem for the tech industry because we figured out pretty early on that rather than have people remember their user IDs for websites, we just have them use their email address for a login. Because everybody has an email, they remember that, so just use that instead. Well, that's now private information. So logging that used to be username logged into cluster name, for example, you can't use the username anymore if that's an email address because that's a GDPR violation. IP addresses are also now considered private information. That was evolving over the 2000s, but GDPR and CCPA both made it very clear this is private data. So keep those in your web server and your load balancer logs and don't put it in your application logs. Related to that, tightly focused geo-IP data. So turning an IP address into a city, state, or in some cases, you can get down to the apartment complex that IP address came from. It's that granular in a lot of cases. So tightly focused information like that is considered private. So use it for fraud fighting. Don't use it for your marketing targeting. Phone numbers and fax numbers, if people still fax, are also considered private. Mailing addresses, names, and these are a kind of privacy that's used in it's not individually identifying, but when used with other information, you can uniquely identify an individual. So all these things are sort of increasingly considered private, and this is still going. As the next 10 years, we may find new data that we consider probably sensitive, but otherwise okay to be actually private as regulation changes. Right now, the EU is going through a standards or regulation setting process regarding how companies process information internally. And they're specifically looking at how marketing departments suck data out of the production systems in order to target people. They're trying to regulate that process, which hasn't had formal regulation before. And we should see some of that soon. Stuff changes all the time. Now, the penalties for mishandling this stuff can be pretty nasty. The payment card industry, if you do it bad enough, will just completely ban your ability to process payment cards, which for a US-based company is pretty nasty because if you can't do credit cards, which is how like 99% of all e-commerce transactions happen from consumers, you're pretty much out of business. You're relying on bank transfers, which is easier for Europeans, which are used to it, or crypto, which is a little dodgy in terms of transaction speeds and everything else. Regulators understand that companies understand money, which is why you get great big fines for getting this stuff wrong, because companies understand money, and going hand in hand with having a great big fine is having a great big public admission of guilt. Mandatory disclosure laws. I believe HIPAA was one of the ones that required this to first, and a lot of regulation is glommed onto it just because it's effective. Companies absolutely would give somebody who suffered a data breach, okay, here's $50,000, but you can't talk about it but you have to sign this NDA and you can't talk about it, which they totally were doing before these regulations came in. But now if it's a big enough thing, you have to publicly admit, yes, we had a problem. Going also with the motivating companies to do the right thing and not hide it in the shadows is to assign civil liability. Now, 2 of the American credit bureaus have had major breaches in the last 3 years, and we're already seeing major class action suits against these companies as a result of this legislation. Well, not legislation, but as a result of this regulation and their mishandling of private data. Also, if you're in an industry such as finance, where the regulators are in the building, getting this wrong means that the regulator is going to pay a lot more attention to you, and they're going to be very keen about your data handling processes, your change management processes, and making sure you're doing it right. Change is going to slow down after this stuff if you get it wrong, and you do need to be careful about that. So into the sources of leaks. In my experience, the biggest source of leak coming into a telemetry pipeline come from exceptions. And here we have 2 example log lines. One, an info opening connection to insurance provider, but the next one is an error in REST client. And we see a class name, an exception in a specific function with 2 parameters, URI and payload. Now, payload is cringeworthy because you have both a name and a diagnosis code, as well as a part of a stack dump in there. And so this is a HIPAA violation. If you see that in your telemetry systems, that can be a major 3-ring circus if it comes out. So what's happening here, though, is that the framework, just because of that, the programming language and the framework you're using here is using a default stack dump formatter to dump out those parameters. Now, parameters are incredibly important for those of us writing software because it tells us what the bad input was that made it go wrong. But the problem is that if you're handling toxic data, those parameters will also contain toxic data. So that's something you shouldn't do in production. But if you can configure your systems to do this, definitely continue doing this in your QA, user acceptance testing, staging, pre-prod environments. Do dump those out so that you can at least test those. And maybe your test suite has both valid and invalid data you throw at your API just to make sure you're testing your exception paths as well as the happy path. But what you want to do is configure your production environments not to event this stuff. Not all can, but if your particular software framework doesn't, the only real fix is to trap all exceptions and explicitly handle them in the redactions in code, and create CI checks to notify not all code is covered in exception handlers. My company actually ran into this. Our HelloWorks product is written with Elixir, which is based on the Erlang VM. And if you haven't heard of that, no surprise. But in the early days, we noticed that some exceptions coming out were coming with full traces, and not just traces, but parameters. So the programming engineers went in to see if they could turn that off. And just that Elixir was so young as a language at that point that they didn't really have a way yet. They fixed it since then. But in that, just when you're using immature languages or stuff that's new and hot, they may not have all the fun features that operationalization requires. So you may have to go to heroic efforts of slathering exception handlers across all of your code just to make sure you trap anything unless it emits something that it shouldn't. This next one is a little bit subtle because it's an example of an actually handled exception, but it's still showing the bad data. So you have an error in this process entitlement request function, and it's received bad API payload and then a dump here. It's a little subtle, but if you look in the actual JSON showing here, you see that they're using smart quotes instead of double quotes in this JSON blodge. Maybe somebody is hand assembling this JSON rather than using a to_JSON function for whatever reason. And so we have this potential HIPAA violation in here. But this type of error is one I want to draw your attention to because it's a pattern I see a lot. And it is probably the second biggest exposure I see after just plain framework exceptions. And it's a logging statement like here. It's using string composition. And so we have a logger.error, so it's an error message. We give it a string, and then we just sort of unconditionally dump whatever our payload was, so the developer can see what happens. So the problem is, anytime you unconditionally dump user-supplied inputs, you potentially leak information. And penetration testers, bug bounty hunters, and other people in the security industry look for this sort of thing because you can do a lot of fun stuff when you have someone unconditionally echoing strings into a logging stream. So go over your code and look for cases where you're doing an unconditional dump like this. This payload thing came in on a payload attribute from the API handler, and something happened. And so you don't want to unconditionally dump that. But you do want to make sure, like before, it's like you can also change this for prod handling. So if your environment variable has an environment prod, you can say, okay, if in prod we just say receive bad API payload and nothing else. But everywhere else, we can actually get the payload string, because that way, if you're in a pre-prod environment, you actually care. It's probably not live data you're playing with, and so it's much safer to see. And if you're fuzzing it internally, you want to see what triggered the exception handler. So also, here's a tip. If you're doing this sort of unconditional exporting of user-supplied data, look for the string wp-admin, especially if you're running a web-based API. Website fuzzers focus heavily on the WordPress admin page because there's so many bugs in there. And if you're not running a WordPress website and someone's hitting wp-admin URLs on your site, someone's up to no good. But if you look through your own centralized logging system, if you haven't, look for that wp-admin string and see where it shows up. If it shows up on like web server logs, cool, that's where it's supposed to be. That's what it's there for. But it starts showing up in your application logs, you probably have some places where you're just unconditionally dumping out URIs somewhere, or maybe parameters or something. Look through those and you may find yourself some leaks to fix. So do that. It's a good leak check. The other great one is not knowing what counts as PII. Here we have a log line using string composition to dump out 2 email addresses to notify of a planned change. Now, as I mentioned, GDPR went into effect in 2018, and there's a lot of software out there that was written before 2018 that is still in use. How often do you go back over your logging statements to vet it for privacy or financial or health information leakages? Probably not as often as you should. So it's been 3 years, you may still have something like this leaking in your system. So what we have here is a leak. So it's source email notified destination email. Maybe that's the user ID. Maybe that's the actual email addresses of what something is transmitted at. Either way, it's private information, and the people who wrote this at the time either was before the time when this was private, or they just never got the memo. It's like people have been treating usernames as emails for, at this point, almost 2 decades. So it's just sort of habitual at this point, especially if you're not in the privacy loops. So this is something that can be a new feature that got developed, and 3 months later, your privacy or your secure cybersecurity team is knocking on your door saying, we have a leak, how did this happen? So be careful about this stuff. This is where structured logging comes in. Now, what you're looking at here is an example of successful structured logging. So we have this notification for plan change, but that first attribute is a simple string. It's not doing interpolation. In fact, this could even be a constant. And that second parameter is a hash or a dictionary of attributes, a simple 1-level hash, source contact, destination contact, plan ID. Instead of email, we're using a contact name, which is an integer, which is probably the primary key on your contacts table in the database, because that's how these things often go. And what we see, instead of that string interpolated logging that we saw before, we have a JSON blob, which is much more easy to ingest in terms of shipping stages and later stage presentation stage stuff for your centralized logging systems. Now, there are 3 components to a structured logger, and the logger, the formatter, and the writer. And every structured logger I've looked at has these concepts in it, although it's a little bit different. The logger is the entry point, and we've seen examples of it so far. That logger.info, logger.error, logger.fatal, whatever it is, that's called inside the production code. That's how the logging chain starts. After that, it's a little different between programming languages, but we have the formatter. The formatter, and there can be more than one reshapes data to make it ready for the shipping stage, which is where it happens after logging exits your production code. It could be just simple reformatting. It could be adding in a bunch of context-related data. It could be redacting a bunch of stuff that shouldn't be there. These things can be granular. And the writer is the one that sends it into the next stage of the telemetry pipeline, be it to a log file, thumping it into an API somewhere, or putting it into a stream, or hitting an RPC endpoint. And also, these often include a final formatter to give it a last touch-up. Maybe this is where encode into protobuf happens, whatever it happens, that happens in the writer. So we're going to look at a few different structured loggers to show how this pattern goes. Now, this is Java's log4j2. Conveniently, the logger is called logger, and it behaves as we've seen before. And it's the parent object of all loggers. It's the logger.fatal, and then you hand it in more attributes. And you can extend this to take additional parameters as you need to. The formatter phase actually has 2 kinds. Log4j considers a layout system, which handles the actual formatting of the emission, which is almost always strings. And that gets it ready for the appender to happen. But also it has a concept of filters, which is a simple yes, no, maybe decision point of, does this log line get to be emitted? Filters are a good spot to put like a PII checker or a health information checker. So if it has health information or privacy information, it just gets a no, and that just doesn't get emitted at all. Just stop it right there. For writers, they have an appender, which is actually what emits it. And you can have more than one appender. Perhaps you have one appender that goes off to sumo logic, another one that goes off to a log file, just so you have a local copy. And filters can also be used at this stage. For example, you could have that PII filter sitting here at the writer instead, where if the PII filter comes back negative, it goes off to sumo logic, the SaaS provider, so you put it there. But if it comes back as positive, that doesn't get emitted to sumo logic, and it goes instead to that log file. So that local log file inside your environment with all the controls that entails stay private. So that private data stays private. Now, I saw JavaScript is something that people talk about here, although I don't think either of us deal with it. But the structured logger in there, one of them is Bunyan, which is formatted very similar. So again, logger is the name of the top one. Unlike Java, the Bunyan logger can take two attributes on that. The first one can be a one-dimensional hash, and the second one is a string that you can pass in, which means you can just pass in a hash with this one. It's kind of cool, and it does it out of the box, so you don't have to make it yourself, unlike the Python one, which doesn't. And the formatter here is the serializer, which is where you would make changes to the object in classic JavaScript way. You get past an object, and the serializer should return a new object after the modification is made, just so that later elements in the logging pipeline can do what they need to do about that one. And the streams is what the writer is for Bunyan, and it has defaults for files and console, but there's a bunch of plugins that allow you to send to this, that, and the other thing. Now, .NET for Serilog, it uses a capital L instead of lowercase l because that's the .NET style. And it prefers more of a string interpolation approach. So you provide it a string template and you feed in attributes to feed into that template. So it already forces you into some level of structure and formalism just by doing it. Now, they also have the concept of enrichers. So as you're creating a new logger, you define enrichers. You can have more than one. And this can add context. The from log context will add like thread ID, process ID, host name, and a few other details for what happened, what the context was when the log was emitted. And syncs are what they call the writer, and can commit to multiple places. And you can write to multiple places as well. So you're like in that sumo logic log file split that can happen. Now, the Python one is, I don't have a slide for that one, but Python has the base logger is pretty well featured, but there's a struct log module that does all of this stuff as well. And the book does have, I use that as my example in the book. So if you're looking for that, definitely take a look at that. But it has loggers, the formatters, they call it processors there. The processors apply in series, and then a final writer, like the final processor, is the one that actually emits things off as you move on. It's pretty well featured. So this is the attributes of why that block earlier was so good for what I'm talking about here. That first thing doesn't use string interpolation. Whenever you do string interpolation, when you're defending against leaks, it's really hard to make sure in a later stage that string that's emitted doesn't have what you're looking for. You're probably dealing with string parsing at that point. So if you can ensure that first entry point doesn't have any string interpolation, it makes the problem so much easier. And that second parameter, or the first parameter for using Bunyan, a hash of context passes an additional parameter. Now, the thing about a hash is that it lets you use a dictionary and provides a little bit of a schema to the type of telemetry you're emitting. So here we have that emission here. It's a hash, it's a schema, it's a date, what you can do is you can actually start building allow and deny lists based on attributes you want to see in your telemetry. It's far faster to deal with a schema approach of this than try to build a complete library of regular expression engines that identifies and redacts or removes telemetry from natural language formatted log files. Like I did that for a while. You can do it. It's leaky and it's painful, and no one can maintain it. These regular expressions just overall aren't a fun thing to play with. Yeah, like I said, it allows you to create a standard set of fields that your logging system will support. And standard fields allow you to simply handle special fields. So like that source and destination contact, maybe you have a source email and a destination email that you know is in there, but you can't allow in. And standard fields make sure that your telemetry pipeline has to do less string processing, which makes it faster and more efficient and easier to maintain. So here's an example. Here we have following the right path, but we have that source email and destination email in there with actual email addresses. But the emitted log line there, the JSON doesn't have them. So I want to show you how you can go from this emission to this input to this emission, getting into the shipping stage. So this is where the formatter comes in. That formatter can be used to modify the telemetry. So the metadata keys coming in, you see on the left-hand side of the screen is all the that hash attributes that came in. And on the right, we have a different table of allowed keys. And what your formatter can do is look at each attribute on the metadata hash one at a time and check to see if it's in the allowed keys. If it's in the allowed keys, put it into the returned hash. And if not, just do nothing and just don't include it, which gives us that bottom hash that we have of returned values. And just as a reminder, for log4j.s, this is the layout. You do it there. And Bunyan, that's the serializer. And Serolog, that's the enricher. And in Python, that'd be a processor if you're using the struct log module. But you can also be aware that the allowed keys table is privileged. So you do want to make sure you're careful with it when you're dealing with code. You don't want it so that software engineers can just update the table and just goes through normal peer level code review, because this is a decision that, is this information privileged? Is this private? Is this subject to regulation? And your average software engineer probably doesn't have that in their head. So you need like a more senior engineer, or maybe somebody involved in compliance or data control to approve new fields to the allowed keys. It should just be a ticky box, but it's something that does need to have a little extra procedure on it when you're dealing with this sort of thing, because you want it to be safe. You want this allowed keys list to be the minimum set that you need to be able to diagnose things, yet still not leak data into your telemetry systems. Now, you could also use this to redact fields. So instead of so you have that allow list in here, but you could have a second table on here for redaction. So you go through your allowed keys and you do that, but then you go through again. And so if it doesn't show up in allowed keys, you check the redact keys table, which has three things, three columns: source name, a destination. Sorry, 2 columns. Getting mixed up my slides. The source key, so source email, and a placeholder that you put in for that one. So it just substitutes in the placeholder values. You might want to do this versus simply removing them, especially if your telemetry pipeline has an expectation of schema. For like, you may actually require these fields in there in order for later formatting to continue. For example, if you're using protobufs, anything in there, that's a very strict format. So you need to put something in those fields, even if it is very small or possibly nulled, to make sure that those things fill out. So this makes your format a little bit more complicated, but it does allow you to keep those attributes that you had. This next example, I do want to show how the difference is. Again, this is the same input that we had before, but if you notice in the bottom part, instead of source email and source email and dest email, we have source contact and dest contact. Something in here translated this email address into those other attributes. And this also can be part of the formatter. So again, we have the allow key table that'll just allows things in, but we also have another table in here for reference. So it's a three column table: source key, target key, and a reference function. In this case, get mail ID, that takes one parameter, the value of the telemetry, and returns whatever the value of the target key is. In this case, an integer, probably the primary key of the contact in the database table, which isn't private. That integer is fine. You can omit that, but the email address itself, because if you actually do care about which email it is, you can look it up in your admin portals, or maybe do a database lookup in a different process, not in your telemetry, to turn out what 88.1.84.82 is in terms of email, and get your TimTam99 example email. So this dereferences. It's a very powerful approach, and this is actually useful in larger code bases when you have a lot of historical logging that you're trying to catch up and trying to clean after time. So like if you've got a small green field, you probably don't need this one, but if you have an old mature code base, this kind of trick can get you out of a lot of trouble. But you can also use the writer part of the structured logger to redirect telemetry. Now, what we have here is a bit more log4j.s here. So we have our logger, and it goes into 2 different appenders, which have the same filter on them. This filter is PII. And so any log event goes to both, and then it both runs through the filter. Now, if isFilter comes off true for the top one, it is denied. It does not allow it through to the normal logging index on Elasticsearch. But for the bottom leg, if that detection does not show any PII. It's blocked from going into restricted logging. What this does is it allows you to fork your logging. So you have your clean stuff going into a normal logging table, and then your restricted stuff going into a different index than the other stuff, which allows you on your presentation side to be able to have kind of wide open access to your normal logging stuff, but kind of keep it nice, short, and tightly focused for the restricted logging. Maybe your compliance team or your security team can only get in there, and there's an approval process to get engineers into that particular one. So this is a way to provide essentially the isolation you need for this private data. Because for the private or health or financial data, a lot of these cases, you need to be very selective in who is allowed to view it. For health information specifically, they're very sensitive about that. So yeah, having an approval, sort of here's your access ticket, it's good for half an hour. You can look at it here in this specific context, which is radically different for how we actually want our telemetry systems to work. But if you have to look at that one value, that's the way you just have to do it. So again, this is how you would set it up in Log4j. We'd have an appender here. There's actually is an Elasticsearch appender for Log4j. It just requires far more attributes to set up than it can really fit on a slide, I'm afraid. So I kind of faked it. But you can see the concept here. So you have an Elasticsearch appender going to the normal logging index, and it has this PII filter. So on match deny, on mismatch neutral, which just means you can either move it on or allow the next filter to move forward. And we have this short little array of fields we consider to be PII. Very simple. You have to write the filter and call it as part of your XML setup, but this is totally doable in there. And looking at the other side for the restricted logging, it's the inverse. So it's the same filter, you just kind of swap the on match and mismatch tuple. So if you're sending to the restricted logging, you want on mismatch deny. No, we don't want any normal logging into the restricted logging side. So but this does allow the PII or anything else to go into this index. It's very powerful things. So detecting toxic data for compliance. Since we do have some people here involving in cybersecurity, this may be something you're already doing. But to be very serious about safely handling toxic data, organizations do need to proactively search for this stuff in their data repositories. Make sure that it's not leaking out of the areas. My company has been doing this for our telemetry systems as well. And there's a variety of services out there that allow you to do these scans. And machine learning features a lot in here just because there's a lot of weird edge cases. You need to handle hyphenation, non-hyphenation, weird markup, and odd string formats, but still. There's three big ones I want to draw attention to. Amazon's Macy service is a managed service that will scan an entire S3 bucket and give you a report of where all the potentially interesting data is in there. Microsoft Presidio is an open source scanner that you can download and run on your own infrastructure to detect sensitive information. GitHub has a PII detection action for GitHub Actions. So like I mentioned a while back that you could put PII formatted data as part of your test suite and then throw it at your system and make sure that it doesn't come out the other side in terms of exception traces or logging or other parts. GitHub Actions allows you to do that. And in fact, that sort of CI system, continuous integration hygiene, is really important, especially if you're getting serious about this. And there's also more SaaS providers that you can shake a stick at that will help you do this for this, that, or the other thing, provide you with that CI system stage to do what GitHub Actions does, or will give you a system that will kind of act as a filter stage as your data moves through its telemetry pipeline to say if you're getting some links. There's a lot out there. But be careful, though. A lot of these tools are prone to false positive detections simply because there's no canonical way to format a lot of this data. So if it looks kind of like it's a detection, a lot of these things will default to that's a detection and leave the humans to sort it out. So my advice to you, software engineers out there, is if you're going to be using these systems on your telemetry systems, pay attention to what the format is of the telemetry you're emitting that isn't at all PII, because you can get a lot of false positive detections. This is fun stuff because, yeah, not looking like sensitive data. Random integers are incredibly prone to false positive detections. Avoid integers of these sizes. 16 digits is a really great one because as software engineers, we think in base 2 just because it's a habit. 2, 4, 8, 16, 32, 64, 128. That series is baked into our heads. And we're picking a random integer size just to create an identifier. One of those numbers shows up. Unfortunately, credit cards are also 16 digits. And if you're creating a lot of random IDs like that, you're going to actually have something that looks like a credit card number. Now, credit cards have a validation algorithm called Lund's algorithm. I think it was made in the 70s. I could be wrong. But if you just create enough random 16-digit integers, you're going to get some that look like credit card numbers. Now, these privacy scanners have no way to make sure that's a valid or useful credit card number. All they care about is that it looks like it could be. So if you're creating a lot of 16-digit integers for like a session ID or an account ID or something, or like a process identifier, for example, then you may end up with a lot of false positives when the scanners run on your system. So to be honest, the easiest way in the world to make this go away is to change that from to a 17-digit integer. It makes that problem go away. But there's other integers to be careful of. 9-digit integers, they look like social security numbers, or can. Again, there's a validation algorithm there. 10-digit integers are fun because they look like US phone numbers with area code, or also integer encoded IPv4 addresses. So just don't use 10-digit integers anywhere. 10 to 13 digits, that's kind of the range for most international phone numbers work. Some kind of ooze out up to 16 digits in some cases, but your 10 to 13 is where the bulk of it is. 32-digit hexadecimal, that's kind of what an IPv6 address looks like. And again, there's a validation algorithm to make sure what looks good and what doesn't. But again, they can throw false positive detections. And anything with an @ in the middle of it, there's a lot of things out there that aren't actually email addresses, just look a lot like them because that thing at thing.thing format is so incredibly common. Like, for example, I believe RabbitMQ for a long time used like q@vhost.broker or something like that. It's not actually an email address, but these scanners can't really tell that. And even though that's just the name of a queue on a queuing system, that's not private information. They'll still flag it because of the format. And finally, IP addresses should stay in your web server. Load balancer logs, don't keep it in your application logs if at all possible. So as you're writing software, this list is useful because just look at how you're handling integers and just make some changes to make sure you're not doing this. Maybe hexify them, turn them into hexadecimal instead of integers. Whatever you need to do, just if you're going to be doing these privacy scanners on your telemetry data, avoid these things. Now, that was a fun romp. So I'm happy to answer the questions from either of you if you want to. Feel free to type them in or talk it out loud if you want. All righty, hearing none, I think it's probably time to close this down. So let's see here. That's us. All righty. So thank you for listening today. Hopefully you got something useful out of that, and maybe you'll give something that can help your coworkers if you're not actually doing software development. Thanks for tuning in.